So you know here you can't just plug in -3 because give you a denominator of 0. But all you have to do really is factor the numerator.
X plus 3x minus 2.
Yeah. Okay, so the limit as x approaches -3 of x squared plus x minus 6 over x plus 3 will just become the limit as x approaches -3, x plus 3, x minus 2 over x plus 3. Okay, so the two x plus 3's cancel out. Which means you have the limit of x minus 2 as x approaches -3. Okay, so if you plug in your -3, you just get -5. Okay. But you still have it to where x can't equal -3. Because all we did was make it a removable discontinuity. That original spot still remains where it's discontinuous. We just were able to find the limit without having to go through all the extra headache.
So does it mean that last one's the same way?
Oh, yeah, I forget to put that. Yep, I forgot to put my x can equal 0. Thank you. Yep, so on the previous one, be sure to put x still can equal 0.
So whenever you remove anything, whatever that equals to 0, you cannot have. So like, for example, the last one is 0. This one, x, if it was -3, it wouldn't.
Yep, whatever made it discontinuous at the beginning would still make it discontinuous. Yeah.
Now, a quick question. When you said x as approach, or the limit axis approaches, say, -6.
Oh, if it's -6
but will we still put the x cannot equal -3?
Oh no, because if you plug in -6 or x approaches -6, if you plug it in and it's not a denominator of 0, then whatever that answer is your limit.
Okay.
Yep.
That's what I was curious.
Oh yeah, the only time you have to worry about that x doesn't equal 3 is if at some point plugging that in will make the denominator 0. If it won't make the denominator 0, just plug it in, move to the next one. All right. Any questions on that one? All right. And I think that's about it. Let me see. I'll do one more just to kind of give you an idea of the different types of problems that'll pop up. Okay, so let's say, for example, if you wanted to find the limit, lower that down, as x approaches 0 of -4, let's say x minus 4. X minus 4 squared minus 16 over -2x. Okay, so we know we can't plug in 0. Okay, but that doesn't mean we can't find the limit. X minus 4 squared minus 16 over -2x. As x approaches 0, we just FOIL that out, since that's just x minus 4 times x minus 4. So I'll do that right on the side. So x minus 4 squared is just x minus 4 times x minus 4. It's just x squared minus 4x minus 4x plus 16. So that's just x squared minus 8x plus 16 right after we combine those two. Okay, so we can replace that with that. So that gives us the limit as x approaches 0 of x squared minus 8x plus 16. You still have that minus 16 right there over negative 2x. All right, so you have negative 16, well, plus 16 minus 16. That cancels out. So that gives you the limit as x approaches 0 of x squared minus 8x over negative 2x, which works out because we can factor an x out of both of those. So you have the limit as x approaches 0 of x times x minus 8 over negative 2x. Okay, so now we have 2x values that can cancel each other out. Okay, so that gives us the limit as x approaches 0 of x minus 8 over negative 2. Okay, so now if we plugged in 0 here, we'd get 0 minus 8 over negative 2, which is just negative 8 over negative 2, which is 4. Oh. Oh. Mm-hmm.
Forgot to write the negative.
No. Yes.
Would you also just cancel out for negative 8x with negative 2x and leave the x squared there, or is that improper?
Oh, no, you wouldn't be able to do that. You can only cancel out when it's just factors. When you have like multiple terms, unless you make it just a series of multiples.
So you have to factor out
Yep, it has to be.
first, and then you can cancel it out.
Yep, exactly.
So the limit is 4, but and x can't equal 0.
Yep, you still have the x can equal 0. All right, so any questions on that one? All right, so yes, unfortunately, factoring comes back. All right, and that is it for today. Did everyone sign in? The sheet should be floating around somewhere. Ah, there it is. All right, have a good one. Oh, let me turn off my recording.